Welcome back, my dear students. Hope that you are all doing fine. Let us now continue where we took off in our lesson in patterns and sequences of Module 1 for the first quarter in our subject Mathematics. Lesson 2 will be all about arithmetic sequences with its definition and characteristics. And before we start, let us remember some helpful tips as we go on with our lesson. You can always pause and play this video whenever is necessary. You can even play back the portion of the video you want to revisit to attain mastery. That's it. I think we are all ready, and let's begin. At the end of this lesson, you'll be able to define what is a sequence. You can differentiate a finite sequence from an infinite sequence and can generate a general rule of the pattern. Now, before we proceed with our lesson, let us first take a look back what we have learned from our previous lesson. Remember in our discussion that a pattern is formed when a set of shapes, numbers, or designs are repeated over and over again. Let us first have a short activity to refresh your minds as what you have learned in our previous lesson. And let's answer the missing value in the sequence and identify the pattern rule. In this sequence, what is the missing value? Correct, it's 38. What is the pattern in the sequence? Yes, you have to subtract the value with 8. Nice. How about this one? What is the missing value? Yes, it's 100. And the pattern? Correct. Just add 15 to the next value. You're doing good. How about this one? What is the missing value? 240. Good job. What did you do? You multiply it by 2 or you will double the next value. And for the last one, what is the missing value there? 243. Right. What is the pattern? By multiplying the value by 3. Genius! Good job, everybody! Now that we have refreshed our mind, we are now ready for the next one. Now remember that the set of numbers and figures in the previous activity are called sequences. And a sequence is a list of things that is usually numbers that are in order. Now there are two types of sequence. One is a finite sequence and the other one is an infinite sequence. Let us now differentiate the two with examples shown in set A and set B. When we look at set A, we can identify the number of values in that sequence. And there are 5 of them, right? So if a sequence has an exact number of object or value, that sequence is a finite sequence. While in set B, though we see 5 numbers in the sequence, you might notice that there is something that follows the last number, and that is the 3 dots. Do you know what those 3 dots means? Yes, there are still value we need to fill in, but we don't know how many more or what number it will end. This type of sequence is an infinite sequence. Each number in the sequence is called a term. So the 3, 5, 7, and 9 are the terms in the sequence. And since the numbers are in order, we will say its position as first term, second term, third term, fourth term, and so on. Sometimes you will hear the word element or member. They just mean the same thing. But for now, we will use the word term. The expression on which defines the sequence is called the general term of the sequence. So using this rule, it is generally easier to find the next nth terms of the given sequences. Now let's take this example. To find the general rule or formula that describes the sequence, we will illustrate is in a table. The upper part of the tables are the terms. Remember the terms where we say first term, second term, and so on? So for every term or position, there is a corresponding value. So in the first term, the value is 2. In the second term, the value is 4. Then 6, 8, 10, 12, and we don't know yet the value of the 20th term, and the nth term in the sequence. To find the rule that describes the sequence, notice that the value of each term is twice the value of the position of each term. So we can say that the value of the 20th term of the sequence is 2 times 20, which is equal to 40. Then the value of the 200th term is 400. In general, the value of the nth term is 2 times n, which means twice the term or the position. I will show another example for you to understand the concept with the use of matchsticks. So let's start. Below are squares formed by matchsticks. Observe how the matchsticks are placed inside each square or group of squares. Now, let us count the number of matchsticks in each figure and record the results in a table. The top row in the table represents the number of squares. 1 for one square, 2 for the two squares that you see here on the figure, 3 and 4 squares respectively. Now, how many matchsticks are there in one square? Correct, there are 4. How about the two squares? Yes, there are 7 matchsticks. How about the next one? Very good, 10. And the 4 squares are 13 matchsticks. Now let's fill in the rest of the table. Do you think you can identify the right answer? If your answers are 16, 19, 22, 25, 28, and 31, you did a great job. How did you find the answer? Let's answer some guide questions so that we can understand what we have done there in our activity. Is there a pattern in the number of matchsticks? Yes, indeed. As you look at the table above, you will see as we increase the number of squares, the number of matchsticks also increase with a certain number. What is the difference between any two consecutive terms? Right, a difference of 3. When we subtract 7 with 4, 10 with 7, we will get a difference of 3. The activity we just did illustrates a sequence where the difference between any two consecutive terms is a constant. In our example, our constant is 3. This constant is called the common difference, and the said sequence is called an arithmetic sequence. So to identify a series of numbers is an arithmetic sequence, you just need to know if the series of numbers have a common difference. Again, an arithmetic sequence is a sequence where every term after the first is obtained by adding a constant called the common difference. The sequence 1, 4, 7, 10, and so on, and 15, 11, 7, 3, and so on, are examples of arithmetic sequences, since each one has a common difference of 3 and negative 4 respectively. Suppose we want to find the 20th, 50th, and the 100th terms of the sequence. How do we get them? Do you think a formula would help? We cannot just write all 20 numbers in the series, or the 50 or 100 of them, because it would be tiresome and impractical. If so, we can find a formula for the nth term of the sequence. In this case, it will be easier since we know the common difference of the sequence. Let us take the first 4 terms. A sub 1 is equal to 4, A sub 2 is equal to 7, A sub 3 is equal to 10, and A sub 4 is equal to 13. How do we obtain the second, third, and fourth? Remember that we have a common difference, that after the first term, we are going to add 3 for the next term. So instead of putting 7 in the second term, we will write 4 plus 3. 4 here is your first term, and we add our common difference, which is 3. For the third term, we bring the value of the second term, and again add our common difference. Remember that the 3 is added always in the next term. So how many 3 will there be in the fifth term? Yes, there will be 4 3's already, and so on. Or we can write the terms this way. Again, first term is 4. In the second term, we copy the value of the first term. Then we need to add the number of common difference in that position. And since there is only 1 3, we write 1 times 3. For the third term, again, copy the value of the first term. Plus, how many 3's are there now in the third term? 2. So we write 2 times 3. In the fourth term, it will be 4 plus 3 times 3. And in the fifth term, it will be 4 plus 4 times 3, and so on. In general, the first n terms of the arithmetic sequence with a sub 1 as first term and d as a common difference are a1. In our table, this is our a1, which is our first term. Then, we have a sub 1 plus d, which is our second term. A sub 1, which is 4, plus our common difference of 3, that is why it is 7. Then followed by a sub 1 plus 2d. Why 2d? Because every time we move to the next term, we add another d, or the common difference that we have. The next term, it will be 3d, and so on. And whatever term will end, it will be written as a sub 1 plus the product of n minus 1 times d. If a sub 1 and d are known, it is easy to find any term in an arithmetic sequence by using the rule a sub n equals a sub 1 plus the product of n minus 1 times d. So by using this rule, it would be easier for us to find the nth term. It may be the 20th, the 50th, or the 100th term in the sequence. You just need to identify the first term and the common difference. Let us now take a couple of examples on how to find the nth term in the sequence. In this sequence, what do you think is the nth term of the sequence? Remember, these are the terms and these are the values. So let us first identify the general rule. What is that again? A sub n equals to a sub 1, which is our first term, plus the product of n minus 1 and d. The d here is our common difference. Remember, we want to know how to find the nth term. And a sub 1 is the first term, and we already have a value for it, which is 3. The n minus 1 is still unknown, but we already know the value of d, which is 3. So let's substitute those. So we have a sub n is equal to 3 plus the product of n minus 1 and 3. This time, let us multiply 3 to n minus 1. So 3 times n is equal to 3n. Then 3 times negative 1 is negative 3. Then group the common terms. But since 3 and negative 3 negate each other, what is left is 3n. Therefore, the formula to find the nth term of this sequence is 3n. So if we will find the value of the 15th term of the sequence, we will just write A sub 15 is equal to 3 times 15, which is equivalent to 45. Let's take the next example. So what's the general rule again? A sub n is equal to A sub 1 plus the product of n minus 1 and d. Then let's substitute. A sub 1 is 13, and the common difference is, since the sequence is decreasing, the common difference is negative 5. Then multiply n minus 1 to negative 5. So negative 5 times n is equal to negative 5n. Then negative 5 times negative 1 will be positive 5. Then let's group the common term. Since 13 and 5 are both positive, we will add both of them. So it will be 18. So the formula to find the nth term of this sequence is 18 minus 5n. That's it. Hope you get the lesson well. If you still have difficulty, you can replay this video until you can attain mastery. If you are now ready, you can answer the next activity on your own. You can always refer to this video or to your module. A sequence or progression is a chain of numbers or other objects that usually follow a particular pattern. The numbers in each sequence are called the terms of the sequence. The expression on which defines the sequence is called the general term of the sequence. That's it! Congratulations! You are now done with this lesson. See you again for our next topic. Bye! Don't forget to like this video and subscribe to my channel for more video lessons in mathematics.